right, this is section 1.1, lines in the plane. Hopefully this is mostly a refresher, stemming all the way back to probably Algebra 1 though. So we have some different equations we're going to talk about. Slope-intercept form of an equation. That is your y equals mx plus b. Remember that m is your slope, b is your y-intercept. The slope formula that people often mistake for a slope-intercept form is just to give me m. Remember that we subtract the y's over subtract the x's. That just means I take the two y coordinates, subtract them, subtract the two x coordinates in the same order, divide. Point slope form is y minus y1 equals m times x minus x1. My slope is m, and x1, y1 is just some point that is on the line. Parallel slopes are equal. Let's jump straight to perpendicular slopes. Those are opposite reciprocals. Remember that means change the sign, positive or negative, and flip the fraction over. And then standard form. We don't use standard form a ton, but it is ax plus by equals c, where a, b, and c are all whole numbers, and a has to be positive. All right, we are now going to graph a line, a refresher of how to graph a line. Remember, we start with the y-intercept. The y-intercept is that b value. Our y-intercept here is the point 0, negative 4. So we start by making that point, 0, negative 4. Our slope here, or m, is negative 1/3. Remember, that is rise over run. So I rise negative 1, so I go down 1, and I run 3. 1, 2, 3. Make a point. I can also go up and left. So up 1, left 3. And then I just connect those, ideally with a ruler or as straight as possible. All right, let's graph this one. This one's not in slope-intercept form. So one option is to put it in slope-intercept form. Take my equation, subtract the x's over, and divide by 2. Y equals negative 2x plus 1. Now I know my y-intercept is 1. My slope is negative 2, so that's rise, negative 2, run 1. So I go down 2, right 1, down 2, right 1, down 2, right 1. Or up and left, up 2, left 1. Connect all my points. And there we go. All right, negative 3x equals 12. Well, I would definitely get my x solved for. So I divide by negative 3. X equals negative 4. X equals, okay, well, x is negative 4. Doesn't say what y is. So it's just anytime x is negative 4. Doesn't matter what y is. X is just negative 4. Oh, look, that's a vertical line. Vertical lines are x equals a value. All right, now we're going to write the equation in slope-intercept and in standard form. Remember, standard form is probably the least likely. 0, 7 with a slope of negative 2. 0, 7, if the first number is 0, if your x is 0, that's your y-intercept. So my b value is 7. My slope, it tells me, is negative 2. So y equals negative 2x plus 7. There's slope-intercept right there. Standard form, we have to get the x's and y's on the same side. So I'd add my 2x. X's come first, plus y equals 7. We need all whole numbers. We have that. X needs to be positive. We have that. There's my standard form. The next one, we have the point negative 4, 5 and a slope of 5 over 2. Well, we have m. This is just some point. Some point meaning x1, y1. I personally like to go to point slope form first. Y minus y1 equals m times x minus x1. First thing here to remember is that minus a negative is really plus a positive. And then we'll want to distribute the 5 halves. So we have y minus 5 equals 5 halves x plus 10. And then solve for y to have slope-intercept form. Add that 5 over. We get y equals 5 over 2x plus 15. All right, now we want to get to standard form though. For standard form, adjust my papers a little. We get the x's to the same side, so subtract 5 over 2x. Put the x's first. And then we need everything to be whole numbers. They're not. And the x has to be positive, which it's not. So to make it a whole number, I just need to multiply by 2. To make it positive, I need to multiply by negative 2. We're going to multiply both sides of the equation by negative 2. Realize we multiply every single thing by negative 2. This first part becomes positive 5x minus 2y equals negative 30. The x is the only one with a special rule that it has to be positive because that's what standard form is. All right, so we are going to find the equation only slope-intercept form this time. But notice that it did not give us the slope. So we have a couple options. I personally would just calculate the slope. We take y2 minus y1, which means pick one of the 2 points to be point 1. Let's choose negative 4, 1 to use first. So I take my y value, which is 1, and I subtract the y value of the other point, which is negative 2. And I take the x value, which is negative 4, and I subtract the x value of the other point, which is 2. Whichever point you use first in the numerator, you have to use first in the denominator. So 1 minus negative 2 is really plus 2, so it's 3. Negative 4 minus 2 is negative 6. Simplify that, we have a slope of negative 1/2. Now I like to go to point slope form. For point slope form, you can choose either of the 2 points to use. I already circled negative 4, 1, so let's use that one. Y minus y1, which will be 1, equals my slope, which is negative 1/2, times x minus x1, which is negative 4. For slope-intercept form, we just need to solve for y, but also simplify that right-hand side. That double negative in the parentheses becomes x plus 4. Distribute my negative 1/2. I have negative 1/2 x minus 2. Add that 1 over. I get y equals negative 1/2 x minus 1. There's my answer. We'll follow the same steps for this second one. First step is pick one of your points to be first. I'm going to pick that first one again. Why not? Find my slope. 5.3 minus 7.1 over 1.1 minus negative 0.9. My brain doesn't want to do that in my head right now. 5.3 minus 7.1 is negative 1.8. And 1.1 minus negative 1.9 is 2. Which means we get negative 0.9, which is negative 9 over 10 when I simplify it. Oops. Here we go. Confirm that with my calculator. 1.8 divided by 2 is indeed 0.9, which is 9/10. All right, now I take y minus a y value. Let's use 5.3 equals m, which is 9/10, times x minus my x value, which is 1.1. Now, one downside of this is that I'm working with fractions and decimals right now, and I hate that. I would switch it to fractions, just because they tend to be more precise usually. I would also say I don't need mixed numbers. Never use mixed numbers. They're awful. So 5.3 is really 53/10. And 1.1 is really 11/10. Look how easy that was. Distribute my negative 9/10. Negative 9/10 x plus 99 over 100. And then I will add that 53 over 10. And the nice thing is to get from tenths to hundredths, I just add a 0. So y equals negative 9/10 x plus 629 100ths. That is how I would recommend leaving your answer. All right, now we're going to write the equation of the line that fits these conditions, and we'll write it in slope intercept and also standard form. It has to pass through the line, or the point, negative 5, 2, and it should be parallel to the line 5x plus 8y equals 4. The easiest way to go about this is to get 5x plus 8y equals 4 into slope-intercept form first. So to do that, we solve for y. I'll subtract my 5x, giving me 8y equals negative 5x plus 4, and then I'll divide by 8, giving me y equals negative 5/8 x plus 1/2. The slope of this line is negative 5/8, which means the slope of a parallel line is the same, so it's also negative 5/8. Now I can write the equation of this line. I take my point, negative 5, 2, do y minus y1, which is 2, equals my slope, negative 5/8, times x minus x1, which is negative 5. Double negative becomes a positive. So x plus 5. Distribute my negative 5/8. Ooh, 25/8. Not a super pretty number, that's fine. We'll add 2. And off to the side here, I'm going to do a little scratch work. Negative 25/8 plus 2. Remember, that's secretly a 2 over 1. We need a common denominator, so we'll multiply by 8. So negative 25/8 plus 16/8, which makes negative 9/8. There we go. Y equals negative 5/8 x minus 9/8. That's our slope-intercept form. Now this question also asked me for standard form, so I'm going to solve. Get the x's on the other side. Add 5/8 x. 5/8 x plus y equals negative 9/8. Well, my x's are positive, but they're not a whole number, so I need to multiply by 8 to make that happen. So I take everything and I multiply it by 8. I get 5x plus 8y equals negative 9. Now, as long as everything is a whole number now, I'm good. If there was still a fraction left, I would still have to multiply by something else to make it whole numbers. All right, same thing. Slope-intercept and standard form again. Let's start with the line we have. X plus 3y equals negative 3. And let's get slope-intercept form. So I'll subtract x. I'll divide by 3, which gives me y equals negative 1/3 x minus 1. The slope of this line is negative 1/3. This question asked for a perpendicular line, though. So perpendicular slopes are opposite reciprocals. Well, the opposite of a negative is a positive. The reciprocal of 1/3 is 3 over 1, or just 3. Now we can take that slope and our point, which is negative 3, negative 5. So y minus negative 5 equals m, which is 3, times x minus negative 3. Now notice when I did minus the negative, I just turned it straight to a plus. Distribute my 3. I get y plus 5 equals 3x plus 9. And subtract that 5 over. I get y equals 3x plus 4. There's my slope-intercept form. For standard form, I'm going to move that x on over, so I'm going to subtract 3x, giving me negative 3x plus y equals 4. Uh-oh, I have whole numbers, but I don't have a positive on my x, so I'll multiply everything by negative 1. Positive 3x minus y equals -4 is my standard form. All right, and we are also going to talk about how you solve these graphically. So on a graphing calculator, right, you got your handy dandy calculator, click y equals. Whatever's in there, clear it. If you have two sides of the equation, which you should have in an equation, right, you'll graph two different lines. y1 will be the first side, y2 will be the other one. So in y1, I'll type 2. Make sure you use this key right here with the x, t, theta, n for your x. -3. And then I go down, y2 will be x minus 1. I hit graph. Now, depending what was going on with your graph beforehand, you could see some wonky stuff here. If you hit zoom and then option 6, which says Z standard, it'll take you back to a window that's -10 to +10 for x and y. Now, the solution to this one equation is when these two things are equal, which means they cross. So I hit second, and then this trace button says calc above it. And you'll notice that you have option 5 is intersect. I want to know when those two lines intersect, so I choose option 5. It says first curve, it's on the blue one. I press enter, yes, I want to use that one. Second curve, it's on the red one. Yeah, that's the other one I want to use. And then it says guess. You can use these arrow keys to get somewhat in the vicinity. The guess really only matters if it intersects more than once, though. I press enter again, and it tells me the intersection is 2, 1, which means they intersect when x is 2 and y is 1. But my original equation doesn't have a y in it. So my answer is just that x value. It is just x equals 2. There's the answer. Inequalities, a little different. I'm going to graph them, those two equal, different y values, right? Okay, my first one, I cleared them both out, x plus 1. Second one, 2x minus 2, graph them. And there we go. All right, so I graphed y1, y2, right? I want to know when y1 is less than or equal to y2. Well, according to my color scheme, y1 was blue, y2 is red. So I want to know when blue is less than or equal to red. Well, that means blue is lower than red. Blue is lower than red up here. It starts at this intersection and goes forever. So I want to find that intersection. So I can calculate, intersect, first curve, second curve, guess. They intersect at 3, 4. So from 3, for my x values, forever, the blue is less than the red. So my answer is that x is greater than or equal to 3, because it started at 3 and went forever. The next one, you have a couple options. You could try to simplify some of that stuff first, or you just go to your calculator and you say, all right, first side is 6x minus 2 times x plus 2 minus 5. Second side is 0. Boom, graph. Get that? 0 gave me a red line across the x-axis. I want to know when blue is greater than or equal to red. Well, that's everywhere from this intersection on up. So second, calculate. Number 5, my intersection. First curve, second curve, guess. They intersect at 2.25. So anytime x is 2.25 or more. So or more means x is greater than or equal to 2.25 is my solution. All right, then you will practice some of this stuff on your own.